The ancient Egyptians used cork for navigation, fishing tools, household applications, and even, remarkably ahead of their time, for the soles of their sandals. The Roman civilization further explored cork's virtues and expanded its applications. They used it to seal amphorae for transporting liquids and to cover the roofs and ceilings of their homes. During the Age of Exploration, cork was used in the Portuguese caravels that set sail in search of new worlds. Despite its many uses, cork has always been closely tied to wine. The bond between this remarkable material and the world of winemaking began in the 17th century with Dom Pérignon. The French monk, famous for his champagne, was dissatisfied with the stoppers used at the time. Those stoppers, wrapped in hemp and soaked in olive oil, failed to guarantee an effective seal. Dom Pérignon instead found an unquestionably better solution in cork. Cork is a raw material with characteristics that no industrial or technological process has been able to replicate to this day. Its chemical composition is truly unique among plant-based materials, and its physical properties make it one of the most flexible and durable substances in nature. Cork's main attributes are its elasticity, lightness, fire resistance, impermeability to liquids and gases, and resistance to humidity, all of which allow it to age without deteriorating. Even though we've come a long way since Dom Pérignon, crafting a cork stopper still requires a patient and meticulous process. Only after the third bark stripping, when the tree is about 43 to 45 years old, does the bark have the right size and quality to produce a single-piece cork stopper. In addition, characteristics such as bark regularity, material porosity, and growth harmony are essential and not always guaranteed for a high-quality stopper suitable for the market. The most prized production is the single-piece cork stopper, made by punching out cylinders directly from the bark. As you can imagine, no two corks are alike. Each is the result of a 100% natural texture, with no standardization or repetition. But how is it made? We asked Carlos de Jesus.
We are carving a high-end natural whole cork stopper directly from the bark of the tree that we saw being harvested recently, and it's not going to be made into something that will protect the wine for, who knows, 1 year, 1 decade,
Yeah.
1 century.
Yeah.
It is quite a magical cellular structure that we have here, and it's wonderful to be able to
Definitely.
start working on that journey that the wine needs to make before we have it.
Definitely. And then once you carved out the cork, the natural cork, what happened then? You apply your technology in order to be sure that the quality is high and it doesn't have defects and TCA, right?
We have a wonderful gift of nature. It's a cellular structure that packs 800 million cells into a tiny little cork. What Amarin does today is to wrap technology around that very unique cellular structure, wrapping science around something that has been on this planet for up to 45 million years. And still today, it can surprise us. The amount of phenolic compound, for example, that you can find in a high-end natural whole cork stopper is going to play a role in the evolution of that wine. The oxygen ingress, well stabilized, consistent, all of these are technicalities that do shape a wine towards reaching that moment where we're all going to be able to enjoy it.
Yeah, I'm impressed about the technology, but I see also a lot of people working in your company
when you talk about sustainability, we cannot just talk about CO2 and the environment. That's of course is very, very important. But what kind of sustainability if we don't count in the human? Yeah. And that is something that we have seen, just like we're doing with Cork, just like we're doing with nature. People are also part of nature, and the men and women, they all play a role. But you know what's wonderful is to see some people that have been working here for 35, 40 years, and their children can today be working here also as engineers, as postdoctorates, operating machines that are so sophisticated that they can find the equivalent of one drop of water in 800 Olympic-sized swimming pools in seconds. Now imagine how proud a father or a mother that has been working here now sees their children operating that high level of sophistication. That, when I come down here to the shop floor, that's something that I always amazed at myself at.
And no part of the cork bark goes to waste. It is fully optimized thanks to the material's incredible versatility. After punching out the single-piece corks, leftover bark is processed into granules for molded technical stoppers. The densest parts, which aren't suitable for stoppers, can be used to produce items for other commercial purposes. Once it has fulfilled its primary function, the cork stopper can be recycled and returned to the economy as a base material for green building or as the foundation for design elements. But is that enough? Is it enough to simply process cork with the right machinery to get a finished product? Not quite. Over the last 25 years, the industry has focused on solving a major issue: removing impurities from cork stoppers. Control and purification processes have reached extremely high levels of efficiency, enough to eliminate cork's main enemy in winemaking, TCA, trichloroanisole, responsible for the infamous cork taint. Miguel Cabral, professor of microbiology at the Faculty of Pharmacy in Porto, was invited to establish the company's technology department in 1999.
We have to have the historical notion that at that time, and already 20-something years ago, cork industry was trying to solve a problem that was a tremendous challenge, and it was creating some doubts in the industry for the future.
Which was this problem?
That problem was the cork taint. What cork taint is TCA. TCA is a compound that is responsible for a moldy taint, and people in general call it inappropriate cork taint because it's not unique from cork. This technology is to detect and quantify TCA. So basically, we individually analyze each cork for TCA. That means that we were able to reduce significantly the time of the analysis in order to be able to do it in a very quick time to be able to have significant productivity. So the norm for TCA analysis, the ISO norm, tells us that each analysis, each sample, takes around 15 minutes. But here, we were able to go down to 15 seconds. That was made with a collaboration between us and a UK company, which was very specialized in chromatography, what they call chromatography tailor-made. So our objective here was TCA, and actually they developed the machines for TCA.
So how many corks can you analyze in, I don't know, one day?
I will tell you in 1 year,
yeah.
We have capacity at the moment for 85 million corks.
Wow. And this is much more precise than the human, analysis, right?
This go down to 0.5 nanograms per liter, which is, below the human threshold. That is around 1 to 2, depend on the type of wine. This project starts in 2008, and the first machines came into the ground, into the shop floor at 2016. It was a really hard, a really hard project to implement.
It's incredible how a familiar object like a cork stopper, once fully understood, reveals its extraordinary character, rooted in its role in winemaking, its natural sustainability, and what it represents for both the environment and economy of the Mediterranean basin. At the end of this journey through the Montado, here's what we can say. The cork stopper encapsulates everything that makes the cork forest a resource worth protecting and passing down to future generations. The bond between nature, humanity, history, technology, and tradition forms a compelling narrative, one that inspires us to better understand today's complexities and face the challenges of tomorrow.